we begin, let's think about patterns. Without looking in the book, what is a pattern? How would you describe a pattern? Carla.
It is numbers, figures, or
Nope, you're looking in the book.
that
I asked,
read.
Carla, you're looking in the book. I asked for people to tell me without looking in the book. Lena.
It's kind of like something that goes in like a pattern.
Well, what does that mean? Remember, you can't use the word in the definition, because if I said, well, if you guys asked me, what does the word defended mean? And I say, well, it means it means to defend. Would that help? No. So don't use the word pattern in your answer. Kingston, what is a pattern? Okay, so Kingston said something that repeats itself. Correct. That is the simple description of a pattern. So, tell me a pattern using letters. Who wants to tell me a pattern using letters? Ethan. A, B, A, B. What will come next, Ethan? A. Next. And let's go one more. A. Yes, the pattern is that A, B repeats. Who can think of another pattern with letters that's a little bit more difficult? Keep your hand up and I'll pick a stick until I get your hand. Carla.
C, B, B, C, B, B.
Good. Carla, what comes next?
C,
Next.
B,
Next.
B,
And let's do one more.
C.
C. Good. So C, B, B repeats. Okay, one more. That's even harder. Sadie's not in here. Zari.
C, B, C, C, D, D.
Oh, hold on.
C.
You gotta go slower than that. That's a good one. But you have to give me at least 2 sets. Like Ethan told me A, B, A, B. And then we continued. Carla told me C, B, B, C, B, B. And then we continued, so you have to tell me 2 times. So start again, but go slow.
C, C, D, E.
D, E. Okay?
C, C, D, E.
So what's the pattern, Zari? Which part repeats?
The CC.
Just CC? That would mean we'd have CC, 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 CC.
CC, D, E, CC, D, E.
Which part repeats? So like CBB repeated here. AB repeated here. So which part repeats?
CC, D, E, CC.
That would mean that it would look like this. If it was CC, DE, CC, that means here's one set, so now we have to repeat it again. CC, DE, CC. And then we'd repeat it again. CC, DE, CC. So Zari, make sure that you're not including too much or too little. Because if it's only CC, then we would just have to repeat CC, 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 CC forever, and so on. If it was only CCD, then we would repeat CCD, 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 and so on. I think and if it's CCDECC, then we'd have to keep repeating CCDECC, CCDECC, which is still a pattern. But I think what you were going for was your pattern. What repeated was CCDE, because you told me CCDE, C, C, D, E, and then we would continue. So this pattern is not C, C, D, E, C, C. Otherwise, we'd have to start with C, C again. So make sure that you are only looking for the part that repeats. Those of you that don't, that just like to rush and get done, you will not do well here because you won't be looking. Sometimes you have to look into like the third and fourth piece of the pattern before you can find what the pattern is. So you've got to be ready to really look, especially once we get into numeric patterns. Okay, so everybody, let's look at page 413, if you're not already there. And please read, let's see, the title of this lesson is Non-Numeric Patterns. Lena, please read this first sentence.
A pattern is a list of numbers, figures, or symbols that follow a rule.
Good, so there's our first vocab word. A pattern is a list of numbers, figures, or symbols that follow a rule. We don't just use letters, we don't just use numbers, sometimes we use little pictures, little symbols, whatever. Lena, read the next part.
In this lesson, you will use a
Here, try again because you read a word, you didn't read the whole word, and so I think now you know what the next word is, but your brain is like, that doesn't make sense, but it's because another word got read wrong. So start again.
In this lesson, you will use and describe patterns that do not use numbers. These are called numeric patterns.
Oh, try again. You're going too fast. So do you see what you're doing? You're just trying to get the word out. But does Nairu, Nair, whatever, does that make sense in the sentence? So do we want to read just to get the word out? No, we want to read so that we understand. So if we read a word and it makes no sense, we have to stop and go back. We're not reading just to get to the end. That's what I need you guys to realize. You're not reading just to get to the end of the sentence or the end of the paragraph or the end of the page or the end of the book. You're reading to understand what's happening. I don't want you to just get the word out and then keep going. I want you to know what it means. So Lena, let's look at this word right here. First, we see a prefix, right? What prefix do we see? What letters make up that prefix? So that would mean the base word is that. Would we have two N's at the beginning of a letter? At the beginning of a word? No. No. So what is the whole prefix? It's something you see a lot. Who can help her out? What is the prefix on this word? Okay, Lena?
ER.
Not E-O-N.
ER.
ER is in the middle of a word. Suffix are the letters at the end. Prefix are letters at the beginning. So the ER is in the middle of the word. Smith. Non. N-O-N. N-O-N, non, is a prefix that means the adjective after doesn't describe whatever the thing you're talking about is. So non-numeric is an adjective. It's a describing word. The prefix non goes at the beginning of an adjective to say that whatever noun that adjective is describing cannot be described using that. So if I'm talking about a non-functional television, functional television means that television's working. But non before functional means I can't describe that TV as functional, which means the TV is not working. So we have non, numeric. So non-numeric. What does numeric kind of look like? What word does numeric kind of look like? Cullen? Number. So numeric is an adjective, meaning that something has numbers. Knowing that non means that whatever it is can't be described as that, what would non-numeric mean? Kingston? There's no numbers. So, try again.
In this lesson,
Just with these are called.
These are called non-numeric patterns. Many non-numeric patterns are shape patterns.
Good. So non-numeric patterns are patterns that what? Victoria,
Their patterns usually
in your own words.
Oh.
Non-numerics are patterns that what?
have shapes.
Okay, but they can have other things too. It just says they usually, or that many are shapes. But non-numeric patterns means the patterns what?
They don't have any numbers in them.
They don't have any numbers. They might have letters. Or letters. Do we call letters shapes? No, they might have shapes. They might have pictures. It may be literal food, like apple, orange, apple, orange. But non-numeric patterns are any patterns with no numbers. So, patterns that do not use numbers are called non-numeric patterns. There's the definition. Non-numeric patterns, patterns that do not use numbers. We know numeric sounds like the word number or looks like the word number. Numeric is an adjective meaning something does have numbers. Non-numeric, that prefix means whatever it is, does not have numbers. Okay, let's look at example 1. Everyone, finger or pencil on example 1. Read in your head while I read out loud. Remember, every period we're going to visualize. Edgar's room has a border of stars and moons. I'm imagining a bedroom with like a little strip of wallpaper around the top that has stars and moons on it. Okay. The stars and moons show a repeating pattern, okay? So that tells me that there's a pattern. Those stars and moons follow a pattern. How many figures are in this pattern unit? Copy and extend the pattern one time. So I'm looking at this picture of his wallpaper. This is just a little piece though. So I'm imagining that this repeats around the whole edge of his bedroom. I have star, moon, moon, star, moon, moon. It's probably going to continue. I know it's a pattern. The problem tells me it's a pattern. So I know it's going to continue. Well, first, the question says how many figures are in the pattern unit. The pattern unit, everybody listen. The pattern, put that down please. The pattern unit is what repeats. The one part that repeats. So in our examples this morning, AB is a pattern unit. CBB is a pattern unit. CCDE is a pattern unit. The one part that repeats is the pattern unit. So I want you to write this definition. Pattern unit. Do you guys remember talking about this last year? The pattern unit is the part that repeats. No extra, just the part that repeats. So if I had a stamp that had AB on it, and I just stamp, 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 that one stamp is the pattern unit. So, step 1 is to find the pattern unit. They redrew the border. Star, moon, moon, star, moon, moon. So now we're looking for the one part that repeats. Would we include star, moon, moon, star, moon, moon as our pattern unit? Does that have one piece that repeats? Smith?
No.
No. We're only looking for the one part that repeats. So our pattern unit is 1 star, 2 moons. So each pattern unit has 1 star and 2 moons. Then the pattern repeats. Make sure when you're doing pattern units, you're not including too many pieces, like saying that the pattern unit is CCDE, CC, or even that you're saying the pattern unit is CCDE, CCDE, or make sure that you're not including not enough, like saying that the pattern unit is CC or CCD. Make sure you are including all the parts that repeat, but only one time. So you have to be real careful that you're not including too much in your pattern unit and that you're not including too little in your pattern unit. You're just looking for the one part that repeats. So we did step 1. How many figures are in this pattern unit? Well, there's 1 star and 2 moons. In all, there's 3 figures in the pattern unit. Now, number 2, extend the pattern. Well, first we're going to copy the pattern that's shown. Star, moon, moon. There's our pattern unit. We're going to repeat it one more time. Star, moon, moon. And now they want us to continue it 1, 2, 3 places. What comes next, class?
Star.
Star. What comes next, class?
Moon.
Moon.
Moon. What comes next, class?
Moon.
If we continued it 2 more, what would come next? Tell me both places. Put your hand up if you want to answer. What would come next? You're telling me 2 more spaces. That's me. Zari, is your hand up? What will come next in those 2 more places?
Star, moon.
Star, moon. So now, the last sentence. So there are blank figures in this pattern unit. In the pattern unit, what are we counting? Are we counting this whole thing? What are we counting if we're counting how many figures there are in the pattern unit? Smith.
Just the symbols in one pattern unit.
Just the symbols in one pattern unit, so just one part that changes. So there are how many figures in the pattern unit? 3. 1 star and 2 moons. 1, 2, 3. So please, this is where you really have to be careful. You may be thinking, oh, patterns are easy. But if you're not paying attention and you're not being careful, if you're looking for a pattern unit, you're going to accidentally include too many. Like you might include this star, or you might not include enough. You might only include the star and the moon. You have to be careful to make sure you're getting the whole pattern unit. I have some people that are not focusing, but you know what? I'm not waiting for you. Not anymore. It's not fair to the people who are. So in example 1, we looked at a repeating pattern. A repeating pattern is just where one pattern unit repeats over and over, like star, moon, moon, star, moon, moon, star, moon, moon, star, moon, moon. But patterns can also grow. They can get larger or smaller. What does that mean? Well, everybody, finger or pencil on example 2. I see your finger or pencil on example 2. Make sure your hand is on your pencil. Zari, I really can't see you. Can you please take that background off? It's not working correctly. Okay. So, read in your head while I read out loud. Remember, every period we're going to stop and we're going to visualize. Sal uses billiard balls to show a growing pattern. Billiard balls are pool balls. These. So I'm imagining Sal, this kid, and he's putting pool balls or billiard balls in a pattern. I'm imagining that it grows. So I'm not imagining like 8-ball, cue ball, 8-ball, cue ball. I'm imagining a growing pattern. That means it's going to get bigger or smaller. Use counters to model and describe the pattern. Well, I don't have enough counters for everybody. I only have like 15 counters total, so we can't do that unfortunately. So we're just going to draw the counters. Then make an observation about the pattern. So here is Sal's growing pattern. Do you see how it gets bigger? He starts with one pool ball and then ends up with 1, 2, 3, 4, 5 pool balls. 5 is bigger than 1, right? So the pattern got larger. It went from 1 pool ball to 5. So we're going to use models we're going to use counters to model the pattern, but we don't have counters. So use some empty space and do this small, like maybe right here, and just do it small. We're going to begin with 1 counter. 1. We can see that each row adds 1 billiard ball or pool ball. So we start with 1, then we end up with 2. So in the second row, we're going to have 1, 2 billiard balls. And then in the third row, we're going to add 1 more. So we're going to end up with 1, 2, 3 counters. Now we're going to continue adding counters or drawing counters until we get to 5 rows. We'll have 1, 2, 3. Here's my 4th. I'm going to add 1 ball. And my 5th, I'm going to add 1 ball. Now I have something that looks like a Christmas tree. So every time, the pattern is to do one thing. I started with 1, then I got 2, then I got 3, then I got 4, then I got 5. It said that each row adds 1 more billiard ball. So that means my pattern is to add 1. I start with 1, then I get 2. What do I do to 1 to get 2, class?
Add another 1.
Add what? What do I do to 1 to get 2? I'm not asking about billiard balls. What do I do to 1 to get 2? This is like a preschool skill. Kingston. Add 1. What do I do to 2 to get 3? Carla.
We add 1 to
Add 1. What do I do to 3 to get 4? Smith.
Add 1.
Add 1. What do I do to 4 to get 5? Mason. Add 1. What do you think I would do next if I wanted to keep going? Ethan. If I wanted to add another row, what would I do? Add 1. If I wanted to add another row after that, what would I do? Cullen.
add 1.
Add 1, and so on. So the number, now this is an observation. Sometimes you have to make an observation. So you have to look. Well, other than adding 1, what is another pattern I see? Well, one that you can say is that the number of billiard balls alternates between odd and what? So here we have an odd number 1, then we have 2, we have an odd number 3, then we have 4, we have an odd number 5. Well, what are 2 and 4? Class?
Even.
Even. So the number of billiard balls in each row alternates between odd and even. So when I'm making an observation, I'm looking for another pattern. I couldn't say each row goes up by 1 because that's my pattern. So when you make an observation, you have to look for something else that's the same. The number of billiard balls is odd than even, odd than even, odd than even. This is where it gets tricky because, and we'll talk more about this tomorrow's lesson. Sometimes it may be like odd, even, 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 even. You can't say in the observation, oh, all of the numbers are even, because is that true? If the first one's odd, even if every single one after is even, are all the numbers even? Ethan?
No.
No, because that first one, is it even?
No.
So is that a pattern?
No.
No. Okay, oh, so here we're going to be seeing a lot of these types of tables. These are called input-output tables. The first row is the input. I put in 1. Second row is output. I get out 1. What did I do to 1 to get 1? What's one thing I can do to 1 to get 1? Kingston. What? I can't hear you. What's one thing I can do to 1 to get 1? Zari.
Add 1 plus 0.
So I could add 0. Well, let's see if the same thing happens the second time. Zari, if I add 0 to 2, will I get 2?
Yes.
Yeah. If I add 0 to 3, will I get 3, Zari?
Yes.
If I add 0 to 4, will I get 4?
Yes.
If I add 0 to 5, will I get 5?
Yes.
Yes. What's something else I can do to 1 to get 1? I can add 0, or I can do one other thing. Colin?
You can multiply 1 times 1.
I can multiply by 1. I'm going to try to show the difference between addition and subtraction. Okay, 1 times 1 is 1. Well, if I multiply 2 by 1, do I get 2, Colin?
Yes.
Yeah. If I multiply 1 by 3, do I get 3?
Yes.
Yeah. If I multiply 4 by 1, do I get 4?
Yes.
If I multiply 5 by 1, do I get 5?
Yes.
Yeah. So sometimes there's more than one pattern, occasionally. Or there's more than one rule, which we'll talk more about tomorrow. Okay, let's go ahead and look at the guided practice, and then you'll have the rest of the time to do the independent practice. Hey, the guided practice says, extend each pattern, draw the shapes on the line. Number 1, we have snails. Now I know you might be being like, how am I supposed to draw a snail? Just do your best.
Okay.
As long as I can tell what the pattern is when you draw your snail, that's all that matters. So, number 1, help me out, Victoria. We have snails. What is the pattern? This snail is
Facing left.
not left.
Right.
Facing the right. This snail is facing the right. Let's put our little note. Well, what is this snail doing?
Facing left.
Facing the left.
Oh, yes.
What is this snail doing?
Facing the right.
Facing the right. What is this snail doing?
Facing left.
Facing the left. Now, let's find the pattern unit. What is the pattern unit?
The first snail, this is the right, and then the second snail faces the left, and then the first snail faces the right, right, left, right, left.
What is the pattern unit? You're telling me the rule. The pattern unit, remember, go back to example 1. What is a pattern unit, Victoria? Focus. What is a pattern unit? Hands down. We wrote the definition. What is the pattern? We wrote the definition. If you follow directions and wrote the definition that I wrote on the board, then you have it.
The part that repeats.
The part that repeats. So is the part that repeats the snail facing the right, the snail facing the left, the snail facing the right, the snail facing the left?
It's the snail facing the right and the snail facing the left.
So it's just, we'll call it the right snail and the left snail. Right snail, left snail. Remember, this is why you have to be careful, because I know Victoria's not the only one that when I said what's the pattern unit thought, oh, it's right, left, right, left, right, left, right, left. I know she is not the only one. Remember, you have to pay close attention. With a repeating pattern, what is the one part that repeats? So, we know it's right, left, which means we're going to keep going. We're going to repeat. We're pretending this is our stamp, like our stamp, you know, with ink and stuff. That's what I mean by stamp. If I went boop, boop, boop with my stamp, what would come next?
Oh.
Victoria?
The snail would be facing right.
Right snail. See, it's not that hard. Doesn't have to look exactly like that because that's a photograph. Then what?
Then the left.
Then a snail
Kind of looks like half snake, half snake.
facing the left. Good. So we have our pattern unit. That's our stamp. 1, 2, 3. Right, left, right, left, right, left. What type of pattern is this? Growing or repeating? Zari.
Repeating.
Repeating. Let's write our note. Remember, repeating pattern just repeats. Doesn't change. There is a pattern unit. Growing patterns don't necessarily have pattern units. Now, let's look at number 2. Oop, Michaela's not here. Sadie's not here. Aaron's not here. Mason is here. So number 2, we have triangle, circle. Triangle, triangle, circle. Triangle, 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 circle. What happens in this pattern? Well, first, is it a growing or a repeating pattern, Mason? Does it just repeat, like we have our stamp and we go boop, boop, boop? Or does it grow? Does something get bigger or smaller? It's a growing pattern because do we have a pattern unit that repeats? Like right, left, right, left, right, left. No. Otherwise, we'd have something like triangle, circle. Well, does it go triangle, circle, triangle, circle, triangle, circle, triangle, circle? No. Would they only show us one pattern unit? So then we're supposed to repeat triangle, circle, triangle, triangle, circle, triangle, triangle, circle, triangle. Wait, I messed up. Triangle, circle, triangle, triangle, circle, triangle, 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 circle, triangle, circle, triangle, triangle, circle, triangle, 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 circle. Do you think that's what they want us to do? What do you think they want us to do? We'll grow the pattern. How is the pattern growing? What are we adding each time? Or taking away each time? Because a growing pattern sometimes gets lower. I know it's confusing, but a growing pattern just means something changes. Something repeats, but it also changes. So what did we do each time? We're adding a triangle each time. So we have triangle, circle. Then we add a triangle, 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 circle. Then we add another triangle, 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 circle. So next, we do a Is that somebody in this classroom or is that outside the room? Making that sound? Is it? Okay. Mason, what comes next? How many triangles are we going to have in this part of the pattern? 4. So what comes next? Then a Are you sure? Circle. Does the number of circles change? No. So what is our pattern? To do what? Add one triangle. Not add one, like in the billiard ball commercial. Example. I don't know why I said commercial. Not add one triangle and circle. We just add one triangle each time. Now, let's make another observation about the pattern in example 2. That's the billiard ball example. What's another pattern that you can find? What's another observation that you see about the billiard ball example? So we already said add one is the rule. That's not an observation. Then we said it goes odd, even, odd, even. What's another one you can make? Oh, wait, I'm sorry. We're doing number 2, not example 2. So what's about this? Sorry. It says example 2, but that's confusing because we do have something called example 2. But no, it wants us to say another pattern about number 2. What's something else you see that you can make? It may not be a pattern, but an observation. Something that you can tell by looking at number 2 will happen all the time. Smith? Okay, that's an observation we can make. If you go backwards, you take a triangle away. So circle, triangle, 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 circle, triangle, 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 circle, triangle, triangle, circle, triangle. Whoops. What's another observation you can make? Victoria?
I understand that. I was just confused about the 4 triangles because there's only 3 triangles in that pattern.
Yeah? And so we add 1 triangle every time. What's 3 plus 1? So we had 1, we added another to get 2, we added another to get 3, and then we added another to get 4. So the next time we repeat it, how many triangles would there be?
5.
5. And then the time after that, how many would there be?
6.
Okay. Cullen, what's another observation about number 2?
It goes triangle. It goes 1 triangle, then a circle, then 2 triangles.
Well, that's the pattern. That's not an observation. That's the pattern. Your observation cannot be what the main pattern is. That'd be telling me, okay, I just figured out that you have to add 2 every time. Ooh, another observation I can make. You add 2 every time. Are those 2 different things? Are they 2 different things? Oh, you add 2 every time. That's the rule. Huh, I noticed something different. You add 2 every time. Are those 2 different things that are happening? No, think. Some of you are just like waiting, you're like, well, what does she want me to say? Let me just say that. You're not thinking about what the actual answer is. You're just trying to get the right answer out, which is not the same thing. Carla, what's another observation? Lena, go ahead. Yeah, go ahead. They can't get in.
Another observation
I said Lena.
is
I said Lena.
He said
that the triangles and the circles are going between even and odd.
The triangles and the circles are going between even and odd. What do you mean?
I mean the triangles are, because
Are they going even and odd?
I mean odd and even.
Odd and even. So if you're saying that they go between odd and even, you need to say it in the right order. So Carla first told us that the triangles change from even to odd. They go even odd. But is that true? Is 1 even? No. So make sure if you're telling me an odd and even observation that you're doing it in the right order. I need people to be paying attention, not working ahead, and not focusing. Because I'm trying to tell you things that are going to help you with your homework. And this is the problem. You don't listen to me when I'm trying to tell you things to help you with your homework. So then you get home and you're crying to your parents that you don't know what to do. Well, guess why that is? Because you're not listening to me when I'm telling you what to do. So there's the problem right there. That's all there is to it. Okay. So yes, make sure that you say, if you're saying an observation with odd and even, make sure you put them in the right order. So we wouldn't say the triangles alternate between even and odd, because the first one's not even. We would say the triangles alternate between odd and even, because 1 is odd, 2 is even, 3 is odd, 4 is even. Okay. You have until 9:30 to complete the independent practice. If you finish, you may work on the first page of the homework. Please go slow. Please pay attention. Please do not rush. Go ahead.